Welcome to the Deep Dive. We're here to plunge into some fascinating sources and pull out the insights you really need. Today, we're digging into the very soul of our built world. We want to unravel the intrinsic character of buildings. It's this delicate dance, isn't it, between timeless craftsmanship and, our evolving moral responsibility in construction
Mm.
across different eras. I'm genuinely excited to see where this goes today, blending that old wisdom with, the urgent stuff we're dealing with now. Ready for some aha
Yeah,
moments.
absolutely. And our mission really is to figure out how buildings actually get character. And like you said, it's not just about how they look, their aesthetic appeal. It's
Hmm.
deeper. It's a reflection of the values, the integrity, the sheer skill that's kind of embedded in how they're made. We'll be tracing this path, from ancient ideals and classical texts right through to today's complex project management guides and those modern sustainability frameworks. It's quite a journey.
Right. And this deep dive, it's really designed for you, the curious learner. We want to cut through the noise, give you a shortcut to understanding these, often surprising insights into how our world gets built. Hopefully, you look at buildings a bit differently after this. Okay, so let's start way back. Antiquity. There's this one figure who always comes up when you talk architecture. Vitruvius, a real giant, it seems. His writings lay this incredibly comprehensive foundation for the craft. What was his vision for an architect? It wasn't just about drawing plans, was it?
No, not at all. It's quite striking, actually. Vitruvius saw the architect not just as a builder, a technician, but as a true polymath,
Hmm.
a universal scholar almost. He laid out this huge breadth of knowledge an architect had to master. It wasn't optional. Think about it. Geometry, obviously, for forms and space, but also astronomy, crucial for orienting buildings, understanding climate, sunlight, even music. He believed music held the keys to proportion and harmony, like mathematical ratios in sound. And then, of course, mechanics for structure, natural philosophy for understanding materials, site conditions. It was this holistic grasp, all aimed at making sure structures were suitable, durable, and, beautiful in a deep way.
That idea of the architect as a universal scholar, it's really inspiring. But it makes you wonder, doesn't it? With all the hyper specialization today, is it even possible for one person to be that Vitruvian ideal anymore? Or has that polymath character maybe just been spread across the whole team? And if so, what does that mean for a building's, soul?
That's a fantastic question. And it really speaks to why Vitruvius still matters. He also had this deep belief in the moral imperative of sharing knowledge. That gets lost sometimes today, I think. He specifically argued against what he called envious silence. He urged thinkers, architects to share their insights, pass them on for the common good, not hoard them. He drew this really interesting contrast between, say, athletes whose fame is fleeting, fades with their strength, and the learned, whose knowledge has lasting utility. For Vitruvius, architectural knowledge, especially when it was written down and shared, was an everlasting possession. It went beyond one person's life, contributing to culture, to society. It wasn't just building things, it was building civilization.
That's success. Yeah, that's profound. It really underlines the responsibility baked into that role. A world away from just a technical, get the job done approach you might see sometimes, almost like being a guardian of knowledge and public well being. So, this big picture thinking, this moral dimension, it must have translated into really practical, long lasting construction, right? How did these ideals show up in the actual building practices, like foundations, for instance? That's pretty fundamental.
Absolutely. The brilliance of Vitruvius wasn't just the philosophy, it was how practical it was. He gave incredibly detailed advice on foundations, knowing they were key for longevity. He described methods for solid ground, sure, but also for tricky spots like loose earth or marshes. You wouldn't just dig a hole, you'd excavate it, everything cleared out completely. Then you drive piles, charred, alder, olive wood, or oak really close together, deep into the soft ground. And the gaps between these piles, filled with charcoal. This created an unbelievably stable, rot-resistant base before the main structure even started. And his foresight wasn't just on land. For bridges, he knew the timing was critical. Build the foundations in autumn when the water's lowest. Smart, right? Ensure stability against currents, erosion. They were building for keeps.
That level of detail for foundations is just wow. And was this kind of thinking common among the classical greats? I'm thinking of Andrea Palladio, another master. Did he just follow Vitruvius, or did he bring his own stamp to this idea of durability?
Oh, Palladio definitely built on that tradition. But he added his own meticulous insights. His 4 books of architecture are full of this stuff. He absolutely echoed the focus on durability. For bridges, for example, he talked about shaping the piers to withstand the fastest currents, really understanding the forces at play. And for walls, he specified they should get thinner as they go up. Not just for looks, but for stability. creating a sort of pyramidal form. Clever physics, really. He even detailed how the middle of the upper wall should sit right over the middle of the lower one for structural integrity, while the inside face can be stepped back to support floors and vaults. It's like a symphony of strength and practical design.
It's so clear they had this deep respect for the materials themselves. What did Vitruvius say about choosing and using them? Was it just about what was nearby or more nuanced?
It was incredibly nuanced, almost scientific. Vitruvius didn't just grab the local stone. He carefully contrasted different types. Soft stones, he said, were fine under cover, protected, but out in the open. Frost and rain would make them crumble. Near the sea, salt would eat them away, and they couldn't handle intense heat. That shows a real understanding of the environment, exposure. On the other hand, travertine, that dense limestone and similar stones, great for loads, great against weather, but vulnerable to fire. Why? Because, he reasoned, they had little moisture or earth, but lots of air and fire in their composition. Fire drives out the air, penetrates the gaps, and causes splitting. That's not just casual observation. It's deep respect, deep knowledge of material properties. Absolutely crucial for responsible, long-lasting building with character.
It really is about forethought, isn't it? A long-term vision, prioritizing durability, working with the environment, not just building quickly or cheaply. Makes you wonder how many of our modern buildings will stand the test of time quite like that.
Okay, so beyond structure, these classical guys achieved incredible visual harmony, real beauty. How did they craft that? Was it just instinct or more calculated? Like designing for the human eye itself?
Oh, it was absolutely calculated, tied into that deep understanding of perception. Vitruvius had these meticulous rules for column proportions and even subtle optical corrections. For instance, he knew columns look thinner when the spaces between them, the intercolumniations, are wider. He called it ocular deception from the open air. So to counteract that visual trick, you make the columns subtly thicker when the spacing is wider. And corner columns, which stand out more against the open air, they were made thicker too, by about a 50th of their diameter, just so they appeared the same size as the others. That's incredible control, understanding how we see things. Visual integrity by design, not accident. That's amazing, like pre-digital image correction. And Palladio, he also gets into really precise methods for harmony, doesn't he? Almost like a mathematical formula for beauty.
He absolutely does. His 4 books are packed with detailed instructions for dividing up elements to get that perfect harmony. Architraves, friezes, cornices, capitals. He has specific ratios for everything, like the height of a vault. Should be half the sum of its length and breadth. Simple rule, profound effect. And he got really granular. He'd break down elements into a main unit, a module. Then he'd subdivide that module into tiny, precise parts. 7 parts for the tinea or benda, those little decorative bands. 6 parts for the gocci and latello, the droplet shapes and thin fillets. Each tiny projection was calculated to contribute to the overall balance.
And it wasn't just about stark geometry, right? There was ornamentation, beauty that told stories in the stone itself.
Exactly. Palladio celebrated those ornate, classical details. He described capitals carved like olive leaves or oak leaves, beautiful, intricate plant forms. He talked about the beautiful inventions on architraves and friezes. He praised capitals as exceedingly well made, wrought in the manner of olive leaves. This signals incredible artistry, a real pursuit of refined beauty, turning stone into something almost alive.
So you have this incredible focus on visual perfection, ornate beauty. But what's really striking about Vitruvius, amidst all the grandeur, is something else entirely. That practical advice. Warning against lead pipes for water, pushing for wholesome clay pipes instead. Think about that. Thousands of years ago, a master architect is prioritizing public health. If they saw the danger in something like a water pipe back then, what blind spots do we have today? Even with all our science, is there a modern equivalent? Maybe materials we think are fine now that future generations will look back on and just shake their heads. Okay, so we've explored this incredible, almost philosophical foundation from classical building. The architect as polymath, materials speaking truth, proportions calculated for beauty and durability. Now let's fast forward like thousands of years, past empires, revolutions, right into today's construction sites. It's dizzying, isn't it? With all our tech, projects on a scale they couldn't even imagine. Has that deep character we talked about just gotten lost in the shuffle, lost in the race for efficiency, or maybe it's just changed into something else?
It is a stark contrast, no doubt. The modern construction world is, well, it's a machine. Immense complexity, massive scale. A far cry from local quarries and individual artisans. You look at someone like Francis D.K. Ching, his illustrations show the sheer breadth of it all. Wildly varied structural patterns, steel, timber, reinforced concrete, super sophisticated foundation systems, caissons, those big watertight structures, soldier piles, sheet piling. Then you've got countless framing materials, endless choices for finishes inside and out, roofing, cladding. And the utility systems, HVC, plumbing, they're engineering marvels in themselves. Just think about walls, solid masonry, composite layers, wood studs, metal cladding. The options are just staggering. Needs huge coordination.
In trying to manage that complexity, standardization must be absolutely critical, almost heroic, right? I mean, you think of organizations like CSI, the Construction Specifications Institute, and their master format system. It's like a universal language for building.
Oh, absolutely. Standardization isn't just helpful, it's essential. CSI's master format is a prime example. It gives everyone, architects, contractors, suppliers, a common language for requirements, products, activities. Imagine the chaos without it. It makes communication possible. And there are real economic benefits too, like in repetitive concrete work. Using standard forms over and over saves money, makes things predictable. It provides that crucial framework for an industry that's incredibly fragmented and specialized. Less diverse teams actually speak the same design and build language.
It really hammers home the scale of it all. Speaking of which, just how big is construction today, like in actual numbers?
Okay, try to wrap your head around this. The U.S. construction industry alone, it's like a giant city constantly building itself. The annual economic output, it blows past $700 billion.
Wow, billion with a B.
Yeah, more than the GDP of some whole countries. You've got over 650,000 different companies involved, from the giants down to tiny specialized outfits. And they employ almost 6.7 million people. It's not just part of the economy. It's like a major engine shaping everything we see, how we live.
100 billion, nearly 7 million people. Vitruvius's lone polymath feels quaint now, doesn't it? But this scale, this push for standardization, it must impact the character of building, right? Does it inevitably squeeze out individual craftsmanship? Or could it, maybe counterintuitively, actually raise the baseline quality by having such robust systems, right? Managing projects that huge with so many moving parts, so much money flying around, it must demand incredibly sophisticated management. How has project management itself evolved to handle this kind of, well, orchestral complexity?
That's where you see a really significant shift. Project management, especially as outlined in the PMBOK guide, that's the project management body of knowledge, kind of the industry Bible.
Mm-hmm.
It's matured a lot. It used to be very prescriptive, do this, then do that, like a strict manual, process-based. But the real world is messy, unpredictable. So now it's moved more towards a principles-based approach. Less about ticking boxes, more about understanding the intended outcomes. What are we really trying to achieve here? Because projects are dynamic, right? Hit by new challenges, changing factors all the time. So the focus is on delivering value, having strong governance, and having really smart risk responses, ones that are timely, cost-effective, realistic, agreed on, and crucially, owned by someone specific. It's about being adaptable, having foresight.
And the type of contract you choose must massively influence how it's all managed, especially the money side. But I wonder, beyond the dollars and cents, how do different contracts affect the character of the relationships on a project, the collaboration, the responsibility?
That's a great point about character. You see a clear difference between, say, stipulated sum or lump sum contracts and unit price contracts. Lump sum gives the owner a guaranteed price for the whole job. Great for budgeting certainty, but it puts all the risk on the contractor to manage costs within that fixed number. They get paid monthly based on percentage complete. Unit price contracts, though, offer flexibility if the amount of work might vary. The job's broken down into items priced per unit, like per cubic yard of concrete or square foot of wall. Payments are based on actual measured quantities put in place. This allows for more adaptation, but it shifts some risk, like quantity estimation, back towards the owner. It changes the dynamic.
That sounds like it could easily become a blame game, especially with so many different companies involved.
Thinking back to Vitruvius wanting shared knowledge, how do modern systems, maybe like Lean or IPD, try to stop that adversarial stuff and actually build collective responsibility? Build character into the project team itself, even with competing subcontractors? Is it more than just the contract? Oh, it absolutely has to be more than just the contract. Subcontractor management is vital, and yeah, it can be tricky. It starts with rigorous pre-qualification, making sure they can actually do the job. Then, having a super clear scope of work to avoid arguments later, and managing shop drawings meticulously. Those detailed fabrication plans from suppliers or subs need careful review and approval. A common flashpoint, though, is when subs claim delays or extra costs, maybe due to unforeseen site issues or holdups by the main contractor. That's where the CPM schedule, the critical path method timeline mapping everything out, becomes this two-edged sword. It helps coordinate, sure, but subs can use it to prove they were delayed by others and claim damages. The real key to avoiding this mess. Fostering open communication, a culture of collaboration from the start, not just falling back on the contract when problems hit.
It all sounds incredibly complex and, yeah, pretty profit-driven. That constant focus on risk and cost must sometimes clash with the idea of embedding deep character in a building. What about the nuts and bolts financially, the risks everyone's taking?
The financial realities are definitely front and center, shaping almost every decision. Take bid bonds, for example. They guarantee the owner that the winning bidder will actually sign the contract. These can be hefty, maybe 20% of the bid price for government work, 5–10% for private jobs. That's serious commitment up front. Then there's the labor burden, payroll taxes, benefits, insurance, which adds a big chunk, often around 31% on top of wages. It's a hidden cost. And retainage. Owners typically hold back about 10% of each payment until the very end. It's leverage, ensures satisfactory work, covers potential defects. These practices really highlight how profit-focused the industry is, the need for tight financial control. And yeah, that can definitely challenge spending extra time or money on bespoke craftsmanship if it's not managed carefully.
And when things inevitably go sideways, like delays, the costs, both money and morale, must just skyrocket, right? Potentially hitting the quality too.
Absolutely. Delays can be incredibly damaging. Financially, you've got acceleration costs, paying extra for overtime, more crews, faster materials to try and catch up. Expensive. Then there's idle equipment. Whether you own it or lease it, it's costing you money just sitting there. Rental fees, depreciation. A real drain. And sometimes owner interference causes problems, like bringing non-union workers onto a union site. That can trigger disputes, work stoppages, huge frustration, more delays. These situations often lead to nasty financial arguments, requiring tons of documentation to prove who's responsible. It adds yet another layer of stress and complexity.
So, okay, despite all these rigid structures, the money pressures, the potential for conflict, is there still room for real flexibility, for innovation? Can modern construction be genuinely agile, or is it just too locked down by process?
That's a crucial question, and maybe surprisingly, the answer is increasingly yes. The PMBOK guide actually stresses adaptability and resilience, because projects rarely go exactly to plan. New needs pop up, issues arise, stakeholders change their minds. The value now is seen in envisioning outcomes rather than deliverables. Meaning, focus on the big picture goals, not just rigidly sticking to a specific output defined months or years ago. Maybe a better solution emerges mid-project, especially with fast-moving tech. The team has to be ready to adapt with strong support from the sponsor and customer. It's about constantly asking, is this still the best way to get where we ultimately need to go?
So what kind of approaches actually support that flexibility, allow for that agile thinking?
Well, you see a clear split. There are predictive methods, sometimes called waterfall. These work okay when requirements are super well-defined and stable up front. Think like building a nuclear plant. You want predictability there. Big upfront investment. High risk if things change. But for projects with lots of innovation, uncertainty, or evolving needs, maybe a cutting-edge lab or a new tech campus, adaptive methods make more sense. These approaches actually embrace change throughout the project. They align perfectly with focusing on outcomes over rigid plans, allowing for continuous learning and adjustment as you go.
And things like integrated project delivery, IPD, and fast tracking seem key for blending design and construction. How do these, especially IPD, help build that deeper character of collaboration we were talking about?
Yeah, they're really fundamental to modern agile building. IPD is intensely collaborative. It deliberately integrates everyone, people, systems, business structures, the whole 9 yards. It tries to harness the talents and insights of all participants, owner, design team, builder, key subcontractors right from the very beginning. The goal: optimize the whole project, boost value for the owner, slash waste, maximize efficiency through every single phase. Fast tracking is often used alongside it, overlapping design and construction phases to speed things up. Starting construction before design is 100% finished. Both prioritize collaboration over rigid sequences. They recognize that getting contractor input early leads to better results, a more unified, responsible approach overall.
Building information modeling, BIM, that seems like a total game changer too, for planning, coordination, like a digital command center for these complex jobs.
BIM is incredibly powerful, a real digital revolution. It's this digital twin of the building, basically. It helps with upfront planning, spotting clashes between systems before they happen on site, sequencing work, coordinating everyone. It can be used for design intent, for construction logistics, even for managing the building after it's built over its whole life. But here's the catch. Getting the whole benefit depends entirely on good BIM execution planning.
The VDC team, virtual design and construction, and the owner need to decide up front how the model will be used, what data goes in, who owns it, what level of detail is needed for different phases. Without that clear plan, it often just ends up being used to automate drawings, not loaded with rich data for its full life cycle potential. It's the plan for the digital plan, if that makes sense. And these methods foster flexibility through specific techniques too, like set-based design. Instead of picking one design early and locking it in, the team explores a whole set of alternatives. They learn from different options, make trade-offs, time versus cost, quality versus risk before committing. Reduces uncertainty, leads to better decisions, and rolling wave planning.
That's planning the near-term stuff in detail, but keeping future plans more high-level. Allows you to constantly refine and adapt as you learn more. Keeping plans realistic and responsive, not rigid.
Okay, we've covered a lot of ground. From ancient polymaths calculating beauty and permanence to modern project managers juggling billions and mind-bending tech. Let's circle back now to that core idea. Character in buildings. How does it show up today, especially with all the pressure for speed, efficiency, profit? Is character just, I don't know, a luxury we can't afford anymore?
This is exactly where someone like John Ruskin becomes so relevant again, maybe more than ever. His writings give us this powerful lens to look at architectural integrity in any era. He famously criticized sacrificing the strength of the living creature in vain, meaning true value isn't just about temporary usefulness or cheap imitation. It's about purpose, inherent worth. A building should be honest about what it is, what it does. And he pointed to the architect's utter neglect of the forms of intermediate stone. That's a scathing critique of carelessness, right? A lack of appreciation for the materials, the hidden labor. He wasn't just talking about the pretty facade. He meant the stones inside the wall, the unseen parts, everything that gives the building its real strength, its integrity. It's about respecting the whole process, every component, seen and unseen.
That's powerful. A real call for truthfulness, rejecting superficiality. And Ruskin also warned, didn't he, that as the system was carried out into continually increasing intricacy, it led to its doom was sealed.
Can we draw a line from that warning about complexity leading to doom to maybe some of our modern challenges, even things like sustainability efforts?
We absolutely can. It's a surprising, maybe uncomfortable parallel. That warning resonates with a modern issue sometimes called lead brain. Now, lead leadership in energy and environmental design, it's a great system, right? But lead brain is when the focus becomes so rigid, so point-based, just chasing certification points, that it can actually stifle genuinely creative, holistic design. Instead of truly innovative, integrated, sustainable solutions, designers might just aim for the easiest points on the checklist. And that can potentially compromise the building's authentic character, its deep, long-term sustainability. It becomes about the certificate, not the inherent value, a bit like Ruskin's fear of intricacy, becoming self-defeating, perhaps. Chasing the system instead of cultivating real integrity. So Ruskin really forces us to ask what true character even means, beyond just looking good or ticking boxes.
He really does. He drew this sharp line between a building's original character, that integrity baked in from honest design and construction, versus accidental beauty or the picturesque, sodden ruin, supposed to consist in decay. It makes you wonder, is character inherent, part of his very being? Or just a surface thing, maybe even something we project onto decay, finding charm in crumbling walls? For Ruskin, real character was in the honesty of the making, the truth of the materials, the integrity of its purpose, not in how romantically it falls apart. It's about being built right, not just looking old.
That's a profound distinction. How do those ideas, integrity, purpose, authenticity, resonate today? Are we still looking for that deeper meaning in buildings, or are we mostly okay with just functional boxes? Which brings us right to it. How does modern construction explicitly tackle this moral responsibility? Answer Ruskin's call for truth and purpose. Is it just about meeting minimum codes, or is there something more going on?
Well, the sustainable construction movement is arguably a direct, powerful answer to that moral call. Its whole point is to minimize resource consumption, ecological damage across a building's entire life, cradle to grave, or ideally cradle to cradle. A key idea is closed-loop materials, designing for reuse and recycling. Imagine aluminum cans just becoming cans again infinitely.
Yeah.
But the reality, many construction materials are just downcyclable. They get reused, yeah, but for lower value things like road base or landfill cover. Better than nothing, sure, but not truly sustainable. And think about the scale of waste. In the U.S. alone, 160 million tons of construction and demolition debris every year. That's a third of our total solid waste, clogging landfills, impacting water. Sustainable construction directly tackles that urgency. Reducing that waste becomes a moral act, an act of stewardship.
And real ND, that certification system, it's like a framework specifically trying to embed that moral responsibility into how we design and build, right? Almost a modern standard for what a good, responsible building should be.
Exactly. LE provides this comprehensive, widely accepted benchmark for green building. Projects earn points in different categories: energy, water, materials, indoor air quality, site impact. Those points lead to different levels: certified, silver, gold, platinum. But the crucial thing, you don't get there alone. LE explicitly requires collaboration. The owner, the whole design team, the builder, the subcontractors, everyone has to be on board, working together. It's a shared commitment to measurable environmental performance, a tangible way of expressing that moral responsibility, that pursuit of building character.
So what are some of those green strategies in practice? Give us a few concrete examples of how this responsibility shows up in the actual design and build.
Okay, so there's a whole toolkit. It starts before you even dig, really. Optimizing how you use the site, integrating with the local ecosystem, thinking about geology, topography, sun paths, solar insulation, water flow, hydrology, wind patterns. Passive design is huge. Orienting the building smartly for daylight, minimizing unwanted heat gain, using high-performance windows, super insulated walls to cut energy loss. Designing for natural ventilation. Things like energy recovery ventilators, ERVs. They bring in fresh air but precondition it using the temperature of the outgoing stale air, saving energy while keeping indoor air healthy. And water strategies are critical. Reducing drinkable water use as much as possible, using rainwater or gray water for irrigation or toilets, specifying high-efficiency fixtures like WaterSense ones that go beyond basic code requirements. These are all conscious choices to build better, more responsibly.
It all points to a really long-term view, doesn't it? Very much like those classical builders thinking centuries ahead, designing for the future, not just for opening day.
Precisely. Sustainable design is inherently long-term thinking. Think about structural heating and cooling embedding pipes in concrete floors or ceilings. Super efficient for temperature control, using the building's mass. And maintaining that performance isn't a one-off. Periodic recommissioning is vital. That means regularly checking and tuning the building systems, HVAC, lighting, controls, to make sure they're still working optimally years down the line. It's like a building's ongoing health check. Also, ethically sourcing materials, like wood from sustainably managed forests, certified by groups like the FSC, Forest Stewardship Council, considering the impact right back to the source, adds another layer of integrity. And let's not forget the big picture, buildings and infrastructure. They're responsible for about 40% of human-caused carbon emissions, and that's projected to hit 50% by 2035 if we don't change course. So sustainable construction isn't just nice to have or trendy. It's a fundamental moral imperative for the planet's future, a true measure of our collective character right now.
Okay, so this pursuit of character, of moral responsibility, it sounds great on paper, but how does it actually play out day to day on a real construction site? What fosters that integrity, that deeper value, amidst all the real-world pressures of time and money?
That's where things like lean construction principles come in. It's a philosophy, often borrowed from high-tech manufacturing, focused on continuous improvement. But how does it foster integrity? Well, lean is obsessed with cutting waste, and not just material waste, scrap wood or whatever. It targets all kinds of waste. Wasted time waiting for materials or information, wasted effort doing rework, wasted potential of people. The goal is maximum value for the customer with minimum waste. That's not just about saving money. It's about respecting resources, time, effort, making sure every step truly adds value. It makes the process itself more honest, more integral to the final product.
And the last planner system, LPS, that sounds like a key lean tool focused on workflow, commitments, almost like a practical moral compass for the daily grind.
Yeah, LPS is fundamental in lean construction. Its whole purpose is to make workflow reliable, making sure people can actually do what they commit to doing. It uses detailed look-ahead planning, identifying and removing roadblocks for upcoming tasks before they become problems. And lots of collaborative pull planning. Teams work backwards from milestones together, figuring out handoffs, making sure everyone understands their part in the sequence. The should, can, will, did framework is key. Making sure tasks that should be done can realistically be done, constraints removed. Then getting reliable commitments on what will be done, and finally critically analyzing why things didn't get done as planned. Planned failures. Then implementing countermeasures so it doesn't happen again. It builds accountability and learning right into the daily rhythm.
Beyond the systems, what about the people? How do these modern approaches build a stronger team culture? One that actually promotes integrity? Maybe like a modern echo of Vitruvius wanting shared knowledge.
That human element is absolutely crucial, especially in approaches like integrated project delivery, IPB. The goal is to build a culture of mutual trust, deep respect, and what they call psychological safety. That means everyone, from the owner down to the newest apprentice, feels safe to speak up, identify problems, suggest improvements without fear of blame. It fosters a team-first or project-first mindset, builds resilience, encourages candid problem-solving. People understand each other's business needs better, even if it's uncomfortable adapting to new ways of working together. That's where true integrity in practice comes from, valuing that human engagement, that collaboration, almost like a modern guild, building something meaningful together.
That focus on collaboration, understanding each other, leveraging everyone's strength, it really echoes Peter Drucker's management ideas, doesn't it? That idea that personal strengths make social benefits.
It's a perfect parallel. Drucker stressed the manager's role in translating objectives, making sure specialists, engineers, architects, contractors can actually understand each other despite their different jargon, and fostering empathy. Understanding how others work, not just what they do. Drucker noted an engineer might value being objective, but a manager needs empathy to handle the non-rational human factors that make teamwork succeed or fail. That's vital for true collaboration, for getting integrated results where everyone's diverse skills combine effectively. It's about building a team where every strength contributes to the building's ultimate character. #outro.
Wow, that brings our deep dive to a close. What a journey. All the way from Vitruvius and Palladio, the polymath architect, the meticulous proportions, building for health and centuries, right through to the sheer scale, the complexity, the profit pressures, but also the evolving values of modern construction. It's been fascinating connecting those dots across time.
It really has. And what's striking, I think, is how movements like sustainable construction, lean methodologies, even though they operate in this wildly different world of speed, cost, tech, they really do echo many of those ancient concerns. They're striving, in their own ways, to embed that deeper character, that integrity into buildings, pushing beyond just function to think about holistic value, ethics, long-term impact. The language is different, the tools are different, but that core aspiration for honest, meaningful buildings seems to endure.
And hopefully for you listening, this underscores that a building's character is so much more than just how it looks on the outside. It's this profound reflection of conscious choices, underlying values, the collaborative sweat and brain power of everyone involved. From the first sketch to the last hidden fastener, maybe you'll start seeing those stories in the walls around you.
Which leaves us with a big question, really. In this era that's so defined by efficiency, by the bottom line, by rapid change, how do we actually ensure that the character we build into our structures truly reflects our highest ideals? Ideals of long-term value, ethical responsibility, and maybe even enduring beauty. What stands out to you as the most critical element for a building to truly have character today?